Next, I would like to introduce our speaker, Brian Tu Van Trang, who is the DevOps engineer at Orange. He will be presenting on the network monitoring as a service.
So, hi, everyone. Thanks for tuning into this presentation. I'm going to talk about the NMaaS platform, which stands for Network Monitoring as a Service. So let's jump right into it. Let's introduce the NMaaS. Network quality and security is crucial for any ISP. However, any monolithic systems isn't tailored for today's ISP's infrastructures. Therefore, we need distributed systems. Here, we'll talk about distributed measurement systems, or DMS. To put it simply, DMS are monitoring applications that are deployed on devices over networks. And these monitoring applications are retrieving network measurements that can be used to be visualized on dashboarding, used for alerting, data studies, etc. Several examples of DMS already exist. For example, SamKnows, which works on private infrastructures in order to measure quality of experience of its end users. Or we also have DMS like CAIDA Ark or RIPE Atlas that studies Internet Tomography on larger scale public infrastructures. Therefore, the complexity of designing such DMS is about scalability and the reliability of these measurements. For instance, since many applications can be hosted on the same device, we have to make sure that these applications do not compete for computing resources so that the collected measurements are not biased. Here, we're simply illustrating applications through their consumptions of RAM over time, and our goal is for them not to overlap. So that's why we are proposing our NMaaS solutions. The NMaaS is an open source platform, which is currently publicly available on Git. And the NMaaS uses the flexibility of container technology in order to deploy and manage applications through a pool of physical machines. To this, we are adding our custom scheduler to the NMaaS, which ensures that these applications do not compete with the resources. The NMaaS is reaching two main use cases that have been mentioned earlier. First, the NMaaS can be a private DMS where one can deploy it on the network and measure its performance and services. The other use case would be that the NMaaS becomes a public DMS where one deploys it on multiple networks as a large-scale public DMS. Through online applications, an NMaaS solution caters to many functionalities. First, one can choose which monitoring applications to deploy from a catalog over their machines in the network. Then one can visualize and manage their pool of machines, as well as the applications that are hosted and running. Then, once that these applications have finished retrieving the measurements, one can examine these results and raise alerts if necessary. Several roles can be used and customized in the NMaaS environment, but we are looking here for four main roles. First of all, we got the user. Simply put, the user logs in the NMaaS, chooses an application, deploys it, and runs the tests. Then we got the node owner, which manages machines over a network. We got the app developer, and as its name suggests, it develops the apps, submits the apps to a catalog. And finally, we got the validator, which lines up nodes, applications, and users for security and compatibility issues. Let's get an overview of the NMaaS. The NMaaS needs several modules in order to work. Since the NMaaS is a distributed system, we want to manage efficiently. So we will be needing orchestration. Furthermore, we want to ease the deployment, which means automation. We also need to store the measurements in a database. And since the data model of these measurements are typically metrics, these metrics will need a collector. Then we will be needing to display these metrics on a graphic user interface. And the dashboard will be here for the user to choose the application and deploy it. Finally, we can add a middleware which links all these services. So the goal here, one of the goals of the NMaaS is to be and stay open source. So we will be using only open source solutions. Since we will be working with Docker containers, we'll be orchestrating with Kubernetes. To configure the server, we'll be automating it with Ansible. For metric collection and storage, we got Prometheus. And as many may know, Grafana will be here to display graphs of data. For the dashboard, we will not be using the default Kubernetes dashboard since we want to add this catalog feature, which is enabled in Rancher. And finally, we suggest to take Istio for the mesh of microservices. Furthermore, we are not using these open source solutions as is because we are basing our network monitoring as a service solutions on previous works. The automatic deployment of a Kubernetes cluster is made available with KubeSpray, and the deployment of a monitoring system on a Kubernetes cluster is also made available with kubeprometheus. As of right now, we are currently working on implementing Rancher, and later on we will be working on Istio. To this, we have several added values. For reminder, we want a catalog. So we'll be using a private local repository so that the app developers can submit their own apps on their own premises. And this is made available and will be generated by KubeSpray. Furthermore, kubeprometheus implements another module with Alert Manager, where users can choose to be notified whenever a metric reaches a specific threshold, whether it's a node metric or an application metric. And finally, with Istio, we are looking for Kiali, which is basically a graphic interface for the meshes of services, where we can see where the applications are hosted and linked to the machines. Now more on the scheduler. The scheduler is, for reminder, here to ensure that applications do not compete with computing resources. This scheduler is based on the Ant colony system that we'll be explaining on the next slide, and it handles requests for deployments. Basically, what does it do? It takes in input the current state of the cluster, machines, and applications currently running and hosted, and gives in output new resource allocations in a schedule with potential migrations over several devices. And these migrations are eased up thanks to the container technology. Now more on the Ant colony system. How does it work? Basically, when an ant is looking for food, it drops some pheromones. And when other ants are also looking for food as well, they will follow a path where there's the highest concentration of pheromones, which with time will lead to the shortest path to this food. Therefore, our scheduler takes inspiration in these Ant colony systems to explore the research space and find the best optimized resource allocations. Now, finally, on the apps catalog. The apps catalog is basically an app store, which is container-based. As of right now, the first catalog contains an IP spoofing detection app, a quality of service measuring app, and a cartography application. Of course, the catalog is not limited to these three applications, since one of our other goals is for you to develop your own applications that you want to test on your own networks. Now let's see what's happening when we deploy the NMaaS. Since we are working with a Kubernetes cluster, we will be using a master worker system. So let's take, for example, one master and two workers. We also want to prove that the master can also be a worker, thanks to the Kubernetes features. We want the NMaaS to be able to scale through several LANs or to work with one LAN only. So we are trusting two machines in a first LAN and another machine in a second LAN. And finally, we wanted to ease the deployments by installing on your own machines, which here is represented by the installer. The first step will be to register all your nodes to the automation tool. Then the second step will be to initialize a cluster with Kubernetes, thanks to all the registered nodes on the automation tool. And once all these platforms and machines have been installed, if we ever want to continue expanding this cluster, the process goes the same way. When we have an additional machine, we'll be registering this machine to the automation agent, and then we'll be adding this machine to the Kubernetes cluster. So what's happening in micro overview? For master and worker, we got the automation agents and an orchestration agent. Thanks to Docker, we got to have a virtual environment for your own applications, and masters and workers can communicate between themselves over a container network. Then the third step would be to install all the modules that we have mentioned earlier: UI, dashboard, database, middleware, application, and metric collectors. How does the workflow goes? Here we got a user that would choose an application on the dashboard and deploy it on the worker. So the dashboard will send the request to Kubernetes that will ask the worker to deploy these applications. Once these applications have finished working, the metric collector will retrieve these measurements and send it to store into the database on the master. Then the user can visualize on the UI the results. In the fourth step, we can add a middleware agent whenever you want to add additional modules to see the compatibility between the database, for example, and the metric collector. Another use of the middleware agent is whenever you want to link two applications that are working together. What about security? For a reminder, we are using Ansible for automation, which means we are registering all the nodes and their credentials. With Ansible Vault encrypts your credentials by concatenating the ciphertexts and the SHA-256 digest. What about the nodes? Well, the NMaaS is based on a cloud structure, which means that you trust your own infrastructure security. Therefore, if anything, we recommend to use a VPN for the deployment. Furthermore, the Kubernetes tool adds a layer for the API traffic with generated certificates and role-based access control. Whenever a user wants to access an application, it will have to use services. Services in Kubernetes are made here to expose a specific endpoint through HTTPS. Now, let's see how we deploy the NMaaS. The first step will be to set up the deployment, which means to update your packages on masters, workers, and your installer. The OpenSSH, Python, and pip package are needed in order to run Ansible. And once you have cloned the repository, you should install the requirements in the file with pip. Then, in the second step, you have to register your nodes by listing all their IP addresses in the inventory. For the credentials, this goes as two sub-steps with Ansible Vaults. First, you need to create for each node a specific file written as is, so between brackets, Vaults, Ansible, user, node 1, node 2, etc. And then on another file, you will create and encrypt with Ansible Vaults a file where you will be putting your real credentials here. So this is the credential for the SSH communication with hostname, password, and the port number. Once this is done, the third step would be to test the connection between all these machines. So with Ansible, it is easy to do this with a simple ping. And once everything goes well, you can launch the deployment with an Ansible playbook command. Finally, once everything has finished, you have to check if everything runs smoothly. Since every modules and services are running on a Kubernetes platform, we'll be using a Kubernetes command to check if all services are running. So in conclusion, the NMaaS platform is here to monitor the network and its services, and it goes on scalability and provides accurate measurements. We want it to be open source so that it is publicly available for the community to use and contribute. We want the automation to ease the deployment of the NMaaS, which for the current state, for example, with social distancing, pandemic, etc., it is quite lockdown friendly since we don't have to go to each machines and configure it on the premises. Then it's also easy and quick to integrate applications on the App Store, the catalog, and where you can test your network with your own applications. And finally, a fourth strength would be the end colony system based that is taking inspiration for the scheduler, which enables proper resource allocation. Thank you for listening.
Thank you, Brian. This is fascinating. I'm actually looking forward to running it on my own network. We have 3 questions so far. Or if anybody else wants to, 4. If anybody else wants to sneak in a last minute one, we'll try to fit it in. But here's the first one. Are all these modules, that is Grafana, Prometheus, and so on, installed in every node?
Well, Grafana and Prometheus are right now installed on the master, on every master that you got. But if you want them to be installed on other nodes, you can. And if you want them to be installed on one machine only, you can as well.
Okay. Are metrics just SNMP and streaming telemetry, or does this extend to things like flow data?
It can measure anything. Actually, that's the point of the NMaaS, as long as you got the right application to test what you want to test. It can be a simple ping latency, or it can be data flow.
Are workers deployed in the network devices themselves?
Well, no, we don't deliver specific network devices or specific electronics for it. We want them to be installed on any server that you possibly have in your networks that you want to analyze.
Okay. Is remote periodic auto discovery supported in this NMaaS? And if so, how is it being implemented?
Can you repeat this?
So it's asking, is remote periodic auto discovery supported? And if so, how are you doing it?
If you're talking about auto discovery for applications, we haven't implemented that yet. The thing is, on the catalog, on the dashboard where you deploy the applications, that's where the NMaaS will acknowledge which application you want to activate and get measurements. So the discovery is not here.
All right, 2 more questions, and then we'll call it a day. How do apps collect information, and how are they written?
The applications collect information. Well, for that, that's according to your development team. Typically, you want to just send any type of measuring tool, network measuring tool. But how are they written and how they are stored? We're working right now to implement these network measurements as YAML files, where we can use the feature of Prometheus that is using metrics, so that it can be efficiently displayed on GUI like Grafana.
Okay, and I think that'll do it. The last question looks like something you've already answered, so we'll skip it, and we're running a bit over time. So thank you very much, Brian. This concludes our session, and we are going to go next into the NANOG community meeting and our conference closing. Thank you again for attending.
Thank you for having me.
you.